Welcome students. In this lecture, we will look at the basic applications of artificial neural networks and also the history and some other introductory concepts of AI. As we have already seen, artificial neural network is one of the significant approaches used for taking any decisions instead of human beings. You can also make use of ANN in any decision support system. So what are the practical applications where you will be asked to make a decision? You can say speech recognition, character recognition, fault diagnosis in manufacturing industries. In all these automated applications, you can make use of artificial neural networks. In addition, you can see any major organization where the entry and the exit are restricted. Only if you have a face application or recognition system, then probably you will be allowed to go inside and out. In such cases, we can make use of ANN. In the medical sector, for any disease diagnosis applications, again we can make use of ANN. For military applications, for image processing with satellite concepts, again we can go for ANN. Nowadays, you can see the restrictions because of the pandemics situation in the complete world. So in that case, people talk about face mask usage and different other concepts. How do you detect a person whether he's wearing face mask or not? Or in a normal traffic application, how do you detect whether a driver or a rider is wearing helmet or not? You can make use of ANN for those applications. Anomaly detections, signature identifications, business or finance predictions, your weather forecasting, very important. And in all these applications you can make use of artificial neural networks. So this is not easy process, it's a challenging process because your data input is going to be continuous and at the same time you are going to expect a higher accuracy from the output system. So how you can tune the system of ANN so that you can get the best result, that's what we are going to see. So this is the history of artificial neural networks. The seed for ANN was planted right in 1940, and from 1940 till your 2023, we have seen a series of changes in the algorithmic aspect and also in the methodology aspect of ANN. What are they? In 1943, we saw that McCullough-Pitts were the first people to introduce the concept of basic artificial neuron, and then Donald Hebb took over and he developed a modification in those neurons and is given in the year 1949. In 1956, again we had the associative memory network which was introduced by Taylor, and 1958 was the breakthrough year where we had the concept of perceptron, which seems to be the preliminary artificial neural network for any deep learning based applications. In 1960, again we had some modifications in the form of Adeline and Medellin. From 1960s to 1980s, all the different types of algorithms, you name any, they were developed between these years. Backpropagation algorithm, winner-take-all algorithm, your multi-layer perceptron, all these concepts were developed between these years. And again, in 1982, we went into the concept of supervised and unsupervised methodologies, where we have a hybridized method in the form of Hopfield neural network. And then we had the Boltzmann machine in 1985. In 1986, we had the Delta rule. 1988, Cosco developed binary associative memory. So when you closely observe these algorithms, you can always clearly say that a technology or any method will always have drawbacks. That's why in the subsequent years, some researchers or scientists are overcoming the drawbacks and they are trying to develop a modified approach. This is the way how technology is evolving, and this is the way how we need to prepare ourselves to. Suppose if you are working in the area of ANN and deep learning. So this is the illustration or the picture talking about the history of artificial neural network. If you closely observe again, you can find there is an AI winter, a commonly used phrase between 1970 and 1990. There was no work done on neural network or say deep learning. The reason is they thought that single layer networks are going to be much more disadvantageous in comparison to multi-layer networks. But at that time, they did not have any multi-layer concepts. So they put all these concepts of single layer perceptron in a shelf, and nobody or none of the researchers, scientists of those era was ready to take up the work. Then came the breakthrough in 1990 in the form of a multi-layer perceptron. And this multi-layer perceptron is the backbone of our lecture session, which is nothing but the deep neural network. Multi-layer perceptron talked about having architectures with more hidden layers. And now in deep neural, we talk about infinite number of hidden layers between the input and output layer. Why? Do you feel that there is also a drawback with multi-layer perceptron or a multi-layer architecture? The answer may be yes, we do not know. However, for all the practical applications, we find that deep neural networks are much more suitable than multi-layer perceptrons or multi-layer architectures. That's why the complete world is running towards your deep neural network in today's scenario for all the practical applications which we saw in